So what we're going to do here for section 1.1, I'm going to do problems number 12, number 18, number 21, number 28. I think that's the last one. So we're going to go ahead and start with number 12. And these problems begin on page 19 in section 1.1. So whenever we solve equations, what we want to do is inverse operations, which is the opposite of what we have. 6 times x is equal to negative 24 is our equation. The inverse of multiplication is division, so we're going to go ahead and divide both sides by 6. The 6's are going to cancel out, or they're going to become a 1, and 1 times x is simply x. And then negative 24 divided by 6 is negative 4. Whenever you solve an equation, you always want to check to make sure that you get the correct answer. And you can see here clearly that our answer excuse me, is in fact x is equal to negative 4. Number 18, we have 2/3 x is equal to 9 over 2. Again, we always want to do inverse operations, but there's an added issue here, and the fact is that a coefficient is a fraction. So we have two things that we can do. The first one is that we can divide by 2/3. We can divide both sides of the equation by 2/3. The second thing is that we can go ahead and multiply by 3 over 2, which is the reciprocal of 2/3. And so if I multiply both sides by 3 over 2, it actually becomes a little easy. Now, by multiplying by 3 over 2, we really do the second step in dividing by 2 over 3, which is when you divide fractions, you actually multiply by the reciprocal. So we're sort of skipping number 1, but you can start it as dividing or just multiply by the reciprocal. Here I have 3 over 2 times 2 over 3, which will give me 6 over 6. And then when I multiply these, I get 27 over 4. 6 over 6 cancels out, or becomes a 1. And so I get x is equal to 27 over 4. Just like we did the first time, we want to check. And so here I get 2/3 times 27 over 4, and we're trying to see if it equals to 9 over 2. I can go ahead and reduce this a little bit. So 2 and 4, 2 goes into 2, 1, into 2 twice. 3 goes into 3 once, and into 27 9 times. 1 times 9 is 9. 1 times 2 is 2. And so you can clearly see that the answer to this one is 27 over 4. There's no need to write this as a mixed number. Improper fraction is perfectly fine. Number 21, we have 2t minus 6 is equal to 3 minus t. What I'm going to do is just add t to both sides. I could have done different things. I just chose to add the t. So 2t plus t will give us 3t. And so the t's on the right side cancel each other out. Now, since I moved the t from this side, from the right side to the left side, I'm going to go ahead and add 6 to both sides. So when I do that, I get that 3t is equal to 9. And then just like the first problem, we're going to go ahead and divide by the coefficient. And so t is equal to 3. And we're going to go ahead and check it to make sure that it's okay. And so we end up with 2 times 3 minus 6 is equal to 3 minus 3. That's 0. And then we can see here clearly that we get 0 is equal to 0, which means that our solution is in fact t is equal to 3. And then the last one, number 28, before we start combining like terms, we're going to have to go ahead and do the distributive property. Students always forget to do the second one, so make sure that you multiply the outside value by everything inside the parentheses. So that's going to give us 6 minus 3x is equal to 2x minus 1. Now I have a negative 3x, so I'm just going to go ahead and add 3x to both sides. And so I get 6 is equal to 5x minus 1. And then here I can add 1, which will give me 7 is equal to 5x. And just like the first one, we can go ahead and divide both sides by 5. So we get 7/5 is equal to x. And so we can go ahead and check it. And so we get 3 times 2 minus 7 over 5 is equal to 2 times 7 over 5 minus 1. So I need a 5 in my denominator in order to subtract these two fractions. And so sometimes the easiest thing to do is just set it up this way, since I need a 5 and it has to be equal to 2. And then I can just simply multiply these. 5 times 2 is 10. So then I get 10 over 5 minus 7 over 5. And then here, I'm just going to go ahead and end up with 14 over 5. I'm just going to go ahead and multiply those out. So 10 over 5 minus 7 fifths is equal to 3 fifths. And then over here, I'm going to write the 1 as 5 over 5. And then 3 times 3 is 9. And then you can clearly see here that when we subtract, we also get 9. So you can see that the answer is, in fact, 7 over 5. Excuse my sloppy handwriting. And that's the end of section 1.1.